Higher exercise 1, part 2, question 6b. Find the equation of the altitude passing through y. Well, remember that an altitude is again a straight line, and this purple dotted line represents the altitude coming from y. An altitude is a straight line that comes from a vertex, y in this case, and cuts the opposite line, in this case xz, at a right angle. Since it's a straight line, an altitude, to find its equation we need two things. We need gradient and we need point. We've got the point. We don't yet have the gradient, but we can find it. If we find the gradient of xz, y2 minus y1 over x2 minus x1, that will be minus 2 minus 2 over 2 subtract minus 4. That will give us minus 4 over 6, and remember to simplify, that is minus 2 over 3. Now that's the gradient of the line xz. We can see that the altitude is a perpendicular line. So for perpendicular lines, remember we're thinking about m1 multiplied by m2 equals negative 1. So to get the gradient of the perpendicular line, we're flipping the fraction and inverting the sign, and the gradient of the altitude is 3 over 2. We've now got the two pieces of information we need. We've got the point, which is 6, 8, and we've got the gradient, which is 3 over 2, and we can sub into y minus b equals m bracket x minus a. So that will be y minus 8 equals 3 over 2 bracket x minus 6. We can multiply through by 2 to get rid of the fraction. 2y minus 16 equals 3 bracket x minus 6. Expanding the bracket, 2y minus 16 equals 3x minus 18. Rearranging the form ax plus by plus c equals 0 gives us 3x minus 2y minus 2 equals 0, and that's the equation of the altitude for question 6b. Question C, find the equation of the perpendicular bisector of xy. This time the blue dotted line represents the perpendicular bisector. Remember, perpendicular bisector is again a straight line. It cuts xy in the middle, and it also cuts at a right angle. Now, just like any other straight line, to find its equation we need a point and we need the gradient. We can find a point by locating the midpoint of xy. That's a point that lies on the perpendicular bisector. So if we find the midpoint of xy, remember it's an average of the x and y coordinates, so it's minus 4 plus 6 over 2 and 2 plus 8 over 2. Minus 4 plus 6 is 2, 2 over 2 is 1, 2 plus 8 is 10, 10 over 2 is 5. The midpoint and the point that we've got for the perpendicular bisector is 1, 5. We can now find the gradient by first of all finding the gradient of xy. So that's going to be 8 minus 2 over 6 subtract minus 4, and that is 6 over 10, which can simplify to 3/5. Again, we're thinking about perpendicular lines, so for the gradient of the perpendicular bisector it's m1 m2 equals negative 1, and the gradient of the perpendicular bisector will be minus 5 over 3. We've got a gradient, we've got a point, and it's y minus b equals m bracket x minus a. Subbing in, that will be y minus 5 equals minus 5 over 3 bracket x minus 1. We can multiply through by 3. That will be 3y minus 15 equals minus 5 bracket x minus 1. Expanding out, 3y minus 15 equals minus 5x plus 5. Rearranging the form ax plus by plus c equals 0 gives us 5x plus 3y minus 20 equals 0, and that's the equation of the perpendicular bisector for question 6c. Question 7. Find the point of intersection of the lines y equals 4x minus 7 and y equals x minus 5. Well, we can find the point of intersection by solving these simultaneous equations. That's equation 1 and equation 2. There's a variety of methods that we could use here, but if we scale up equation 2 by multiplying through by 4, we'll get 4y equals 4x minus 20, and that's equation 3. If we bring down equation 1, that is y equals 4x minus 7, and that's equation 1. Now we can get rid of the 4x's by subtracting, so if we do equation 1, take away 3, take away equation 1, 4y take away y gives us 3y, the x's cancel out, and minus 20 minus 7 is minus 20 plus 7, so 3y is equal to minus 13, and y is equal to minus 13 over 3. We know that y is equal to x minus 5, and if we turn that around, x minus 5 is equal to y, and x is equal to y plus 5. Y is minus 13 over 3, and we're adding on 5. If we get the same denominator, that's minus 13 over 3 plus 15 over 3, and the x coordinate is 2 over 3. Remember to put down the point of intersection in brackets, and it's 2/3 minus 13 over 3. And that's the solution for question 7.